Hello everybody, my name is Dara Hanley and I'm here to present the third place solution to this year's edition of the RSNA Cervical Spine Fracture Detection Challenge. And I'm very sorry I couldn't make it. I was there 2 years ago at the conference, 3 years ago now, and I really enjoyed it, so I hope you're all having a good time. A little introduction to myself. I am an AI researcher at Doubleyard who focuses on the education and government space, and I am competing on competitions grandmaster on Kaggle and ranked 37th in the world. I jumped quite a bit with this competition, so it's quite good. I'll show you through the solution which was developed. So there's four main stages in the solution. The first part is to generate bounding boxes based on the segmentations we were provided with. And what we do is we get the for all the vertebrae, we get the largest bounding box over the area. And we crop the images based on that. But first we need to train a model to actually learn where the vertebrae are in the bounding boxes. So we trained that up, and then we're able to crop out tighter areas from the 3D DICOM. The next stage is again using the segmentations, and for each slice we calculate, not with a model, we just you know, we measure the number of pixels in each slice for each vertebrae, and we divide that by the max number of pixels for that vertebrae in any slice. And using that, we get like an area, a type of area ratio for each vertebrae. So how much compared to the max, to the largest size of that vertebrae, how much of that vertebrae is in this slice. And it's sort of time-wise here, you can see it rolling out, and each of the vertebrae working across. And we can turn that into fracture labels, just taking this, copying this, and zeroing out where there's no fracture. And then we get fracture labels. So in this case, C5, C6, and C7 have fractures, and the rest don't. Next thing we do is we train Slicewise models to learn these ratios. The Slicewise models, how they work is we take random windows of the DICOMs, and we learn for each of those those slice ratio labels. We learn those. So we take out a 96 slice window out of the DICOM, pass that through a CNN, ResNet, I think, ResNext, and then through an LSTM. And then for each slice, we predict out the vertebrae ratio in that slice for each vertebrae, and if there's a fracture in that vertebrae in the slice. So this model runs quite long, around 9 hours, I think. And but we use this in the next stage. We have basically the same model. We take from the previous training, we take the CNN, we freeze the CNN layer here. We take the CNN weights that were trained up in the previous stage. We pass that again through a new LSTM, newly initialized LSTM and linear layer. And then from that, we learn the final study level labels for if there's a fracture in the DICOM and on which vertebrae is that fracture. And then we can make the final levels. So yeah, once again, I thank you for hosting the competition. I really enjoyed it. And I'm looking forward and hoping that you'll release out one next year as well. Thank you.